first we'll discuss in general about blood. So what is blood? Yeah. What is the functions of blood? Why do we need blood?
So, for nutrients के लिए सर कि वो हमारी बॉडी में
Okay, you are saying blood is required for nutrients. Okay, very good. Okay, it will supply all nutrients to all the tissues. Next, what is other function of blood?
ब्रेन तक ऑक्सीजन पहुंचाता है, ब्रेन तक ऑक्सीजन पहुंचाता है
Okay,
और
so you
parts
carry oxygen and carbon dioxide. That is another function of blood. Yeah, respiratory gases will be distributed in the body. The next one. What are the other functions?
सर फॉरेन पैथोजेंस जो होते हैं उनसे फाइट
Okay, you are saying immune function.
यस सर
So immune function is one of the part of blood. Very good. Any other functions?
फाइट करता है।
Fighting against microorganisms. That is immune function.
Yes.
Then any other functions of blood? Any idea?
अभी याद नहीं आ रहा सर
Yeah. Now listen. This is one of the very challenging situation in evolution. If you see any living organisms, they have this blood, right? So actually, I need more points. Can you tell me other points of blood functions? See, blood will be always in flowing state. It will always flow in the body. So that also provides blood pressure.
यस सर
So blood pressure can be happen only when we have a blood, right? The heart rhythm can be done, facilitated by moving blood.
यस सर
Now the challenge was, if you get any cut, immediately what happens? The blood, it will start bleeding,
यस सर
and that is a very dangerous situation. If you bleeding, you will continuously you will die due to loss of blood.
यस सर
So blood also have a mechanism of arresting of bleeding.
यस सर
The, it will only clot
यस सर
where there is an injury,
यस सर
but blood won't clot inside the body.
यस सर
How the blood knows this thing? This phenomenon is called hemostasis, by the way. Clotting mechanism, simply.
यस सर
Clotting mechanism is one of the important function of blood. It will only clot once blood coming outside the body, but not inside.
यस सर
How is it possible? Any idea so far? Okay, that will be okay. So clotting mechanism is one of the function of blood. Any other functions of blood? Do you know? Any other reasons? Some interesting reasons for why do we need blood? Any other reasons? So yeah, I will discuss something very interesting, but it is very connected to blood. The reason was, how many of you know about genes? We all know, right? Blue genes, torn genes. So let me draw genes here. So this is a genes fact. Okay? And let us assume this is a torn genes. Okay? Maybe this genes has a torn here. Okay? So this is genes 1. And I have another genes fact. This is also a torn genes, but it has a patch here. Okay? So in genetic pool or in outside, we have animals or we have genes and they have some errors. Not everyone is perfect actually. Everyone has some errors, just like this genes facts.
यस
Now let us assume, if this gene given a baby, and baby also have similar patch because they get those genes from their parents. If these two, if this is a mother and this is a son, okay, evolutionary, from evolution point of view, a dog, a baby dog after becoming adult, it might participate sex with the mother. They don't have the rules like humans. That's their nature. Now what I was trying to say is, if this son has participated, if they bear a child, definitely they will get the same gene problem continuously in their generations, and that is not good. This is not good because if they have any heart disease is going in next generations because they are inbreeding. Right? That is a problem. That's why even in humans we won't marry our close relatives or cousins We
Yes,
won't. We will go with distant families, other families.
Yes, sir.
The reason is, I will let you know. Imagine if these two get married. If these genes and these genes married, now some interesting thing happens. The first gene has an issue here, but the second fat has a clot here. So this her issue was nullified by this fat. Here they don't have any problem. Same, this gene's issue will be nullified by her good genes.
Yes, sir.
So output will be a good fat,
Yes, sir.
non-don genes.
Yes, sir.
So this is the same reason why evolution favored heterosexual, favorism actually. Okay. So evolution always tried to have you participate sex with another gender. That is first rule. That's why we have opposite genders. So we will have different codes. So when we are mixing, still there is a less chance of getting same mistake again. Then we have second rule, that is married distance cousins, not close relatives.
Yes, sir.
Okay. Now these things we humans understood by science. But how can we teach these things to an animal? We can't teach them,
Yes, sir.
right?
Yes, sir.
So evolution should come with some punishment to teach them a lesson. And what evolution did was, if you are really marrying your close relative, you will die. How they will die? Their blood will clot. Their blood will have some issues. How I will let you know. See, that's why, when they are doing their sex with their two different groups, when they are doing sex, definitely there is a chance that the male blood will be introduced into the female body. Now female immune system will recognize the other's blood group. Now she will develop antibodies. If the baby has a similar group, the father's group, if it is matching, the baby will be died. It will be aborted. This is called erythroblastosis fetalis. Okay, so now they are trying to have various blood groups in the gene pool, and blood groups will act as a weapon to minimize such a inbreeding. And that is why today we have blood groups.
Yes, sir.
Got my point?
Yes, sir.
Blood groups are evolved to counterattack these problems, these genetic problems. Let me give 2 to 3 types of blood groups in the gene pool, in the people. So this blood will eliminate them. If anyone trying to have a close relative who babies, this blood will incompatible, and those antibodies will kill the fetus. That fetus can't even have a child next because it is died at a young age. So now we understood why we need blood groups in the population. The grouping will help them to have a healthy genes in the population, to mix with the other healthy, other people, outsiders, not inbreeding.
Yes, sir.
So now see, we saw something interesting, function of the blood. We underestimated why we have blood groups. We never thought why we are having blood groups. This is one of the reasons. We have healthy gene pool. Okay. Yeah. So now we understood why we need blood group.
Yes, sir.
So blood group is very important, just like the genes.
Yes, sir.
Interestingly, genes also actually G and S, G and S. Okay, that is genes. Yeah. Now let us see some interesting things. So this is the problem. Initially, there are poets. Everyone used to say some big words that we all have same blood. That's a wrong statement. They thought we all have lal blood, right? Red color blood.
Yes.
No, that's not true. Our bloods are different, first of all. So we are all not same from the point of view of blood. But this is not the case 100 years ago. So what they thought, okay, one person undergoing surgery, he lost a huge blood, maybe some hand cutted. Then what they did, they took a pig. They started giving pig blood to the humans. Or they slaughtered a monkey. They started giving monkey blood. They thought everyone has red blood, so let us do transplantation. They are doing it literally. They will keep one pipe in one hand and another pipe to any goat. And now goat blood will be transfused. And sometimes out of 100 surgeries, 2 persons are leaving somehow. That's just a mere chance.
Yes, sir.
It's not because of gold blood, self-sustaining. His blood started, regrowing, not from outside. So, but they understood, rather than not giving blood, when we are giving some other animals any blood, there is a chance that he might be alive. 2 patients are being alive. Rather than leaving him alone, let us do blood transplantation. So they started doing blood transplantation. But the problem was, the chance of death is very high. 98% they are dying, only 2% are living. So this is the common problem. So different, across the world, they have multiple practices. Some, if you go to China, they will say, we are using chicken blood and that's okay, better results. And some Canada, they are saying we are using monkey blood, okay. But there is no uniformity and everywhere death rate is high. Then came one person. He is an immunologist, okay. So this person name was Carl Landstein. What this person did was, he took all the death records of all the people. How many people exchanged blood, what blood received to what person. He checked all the reports, some 1 lakh reports, 10,000 reports he took. He started observing. Then he observed one thing. At the end of the day, when he was taking a blood and keeping on a slide, he is getting 2 types. One was, broadly humans have 2 variations. If red blood cell has an antigen, that antigen he said as an A antigen. And he also figured, if the people have A antigen, they don't have B antigen, so he categorized them as A people, group A people. Let me tell you later story. So, whomsoever having this A antigen, he said them as A group people. So, he was trying to understand how many groups present in the public. Then, he also saw another group of people, they have B antigen. Then he started trying to see any other groups, C group, D group, E group, F group. So he even working on C group, D group, E group, F group, he is working on them. Then he found something interesting in C group. In C group, what happened was, some people have both A and B group. Initially he thought that is a different group. Once he started analyzing them, he understood, these are both A and B only. It's not a new group, it's an old group only. Some people have both A group and B group on their red blood cell antigens. And he kept a D group also. So he thought humans have 4 groups. After his studies, he understood there are 4 groups in humans. But he don't know exactly what are those groups. So he is working on it. Then he understood this 4th group have nothing on the red blood cell, that's it. They don't have A antigen or they don't have B antigen. So that is not a D group, that's just reverse only. Presence or absence of A or B. And that's it, game over. He came to know that all humans have only these 4 groups. Either it is a group or B group, AB group or O group. These are the 4 blood groups in humans. A simple study. Then he started saying, okay, if you have A group, and I found that girl, she also have A group, you both do blood transfusion. And suddenly, 99% success rate happened in blood transfusion. Only, when we are doing 100 transfusions, only 1% died. So see, from 98 dead person to 1%, how improvised his work was. Very great person. Such a great observation, that's it. He haven't done any research, a simple observation. He categorized people, he understood, okay, A group, B group, A, B group, O group. O group, O group, you do transfusion, B group, you do, nothing happens. Okay, even if you have a family of 7 members, he categorized them. Mother, what is your group? Father, what is your group? Siblings, what are your groups? Okay, your mother has O, this sibling has O, you both can exchange, but not others.
Yes.
Simple thing.
Yes.
Yeah. So the success rate was very high. So Karl Landsteiner became, a global celebrity suddenly. And Karl Landsteiner now we got how to do blood transfusions. So everyone was happy. Then Karl Landsteiner still have a problem. People are always, we can say, selfish. So 97% is the success rate, but 3% still dying. And Karl Landsteiner don't know why these people are dying. He know that A group and she is A group. I given blood. Sometimes this person was dying even after giving same group. And Karl Landsteiner don't have any explanation. He's thinking maybe some infection, something. But he was quiet. He was, next 15 years, Karl Landsteiner working on this problem. Why this 3% death rate is there? My theory is okay, widely accepted, widely working, but still, why say A group when we are giving to him, he is dying? What is the reason? He is unable to get it. So he started trying to understand this problem with other animals going across the world, he is working. Then came one person from one area, German or some area. He found that humans' blood reacting with one of the animal blood. Humans' blood was reacting with some animals. So he broadly categorized, that person said, forget Karl Landsteiner, maybe there is a new groups in humans. If the human blood reacting with this animal blood, that is group A. If human blood not reacting with this animal, then this is group B. He given a new system. He didn't say 4 groups, rather than only 2 groups in humans. And that his person was, his name was Alexander S. Weiner. His photo is there on that wall.
Yes, sir.
Immediately Alexander Weiner sent his data to the Karl Landsteiner. Karl Landsteiner, I found something might be useful to you. Let us work together. And what he saw, he was working on an animal called macaque monkey, rhesus monkey. Rhesus, it's a common monkey in India actually.
Yes, sir.
So he was taking his monkey blood and he is reacting with the human blood. He is taking drop of human blood, drop of monkey blood. If they are reacting, that is positive blood. If they are not reacting, negative blood. Now they combine positive, negative with the ABO grouping. And overnight the success rate become 99.9%. This is the last final blood group we accepted. So all 4 groups, either they are positive group or negative group, positive group or negative group, positive or negative, positive or negative. So that is a D group, or it is also called as RH group. Why it is called RH group? The monkey name, rhesus, RHASUS, rhesus monkey, rhesus, RH factor. If humans have RH factor, that is called RH positive blood. If they don't have RH negative blood. Now we have how many groups? 8 groups. A positive,
A
A
negative,
negative,
B
B
positive,
positive, B negative, AB positive,
AB negative,
AB negative,
O
O
positive,
positive,
O
O
negative.
negative. And now what happened after this blood grouping system? The highest, the best prize a scientist can get is a Nobel Prize. And they both share Nobel Prize proudly. And they have saved millions of people across the globe. Even till today we are using their grouping system. A simple observation. Yeah, that is how we have found this ABO grouping system. Okay, ABO grouping system was developed by Karl Landsteiner and RH typing was developed by a scientist called Alexander S. Weiner. Okay, and RH factor, it is called as RH factor, or it is also called as anti-CRP. Then Karl Landsteiner gave some laws, some rules of transfusion. He given some strict rules. These are the rules everyone must follow. And there is a beautiful statement by Karl Landsteiner, a single 2-sentence statement. He said that, write down this statement, Karl Landsteiner law. This is called as Karl-Steiner law. This Karl-Steiner law states that, very important. Water loss. Very bad. Another Karl-Steiner. Very bad. Okay. See. Karl-Steiner said like this. If a particular agglutinogen, I'm writing two terms here, keep in mind. AGGLU, agglutinogen, GEN, okay? Antigen that is. And another one is agglutinin, AGGULUTININ, agglutinin, that is called antibody. These are the words I will use now. He said, if a particular agglutinogen present on the surface of red blood cell, the corresponding agglutinin within the bracket antibody, the corresponding agglutinin must be absent in the plasma. The corresponding agglutinin must be absent in the plasma. This is the simple rule. The corresponding agglutinin must be absent in the plasma. Now listen students what he is trying to say. See, if this is an A antigen, and if I target it with a antibody, what happens to this? A antibody will attack A antigen and the red blood cell will be lysed. A antigen is targeted by A antibody, and what happens? Blood will be lysed. So ideally, if a red blood cell has a antigen, do that person will have A antibodies in his plasma? Never. He should not have A antibodies. If he have A antibodies, what happens? He self-destroy his own blood group. That is the statement. If a particular agglutinogen present on red blood cell, the corresponding agglutinin, the corresponding antibody, that means A antibody must be absent. Since we came to know that the humans have only A or B antigens, now see what happens. There is a table, I forgot how to draw it. If A antigen, A group, what antibodies they will have? They will have B antibodies in their plasma. Got my point?
Yes, sir.
In the A group individuals, they will have B antibodies, but not A antibodies. In B group individuals, they will have
A antibodies.
A antibodies. In AB group individuals, they will have nothing. In AB group individuals, they don't have both A and B. How can they have A and B? Because both the antigens are present. So both the antibodies are absent in their plasma. And last and final. In O group, both A and B antibodies are present. Both A and B antibodies present in O group. Is it clear so far? What antigens and what antibodies present in the plasma and surface of red blood cell. I have given you what is ABO grouping. I discussed about RH typing. Then I discussed faculty. Yes. Then I discussed about Karl-Steiner law. Tomorrow I will discuss about transfusion law. Okay. Then I will discuss.